All right, and so next we are going to hear from Sarah Tefft, who's going to talk to us about the exciting research project that's going on at the Children's Hospital of Philadelphia that DSF just awarded a grant for in 2023. They're here recruiting, and she's going to give us some more information about that.
Hi, everyone. First, I want to introduce Arjun Pillai, who's one of our researchers, who's going to talk a little bit about his story. He works in Dr. Helbig's lab, and he's here to help us recruit this weekend as well. And then I'll go into my slides. So thank you. Arjun?
Good morning, everyone. My name is Arjun Pillai, and I would like to talk about my own personal journey with SCN1A. I carry a change in the SCN1A gene, which is the cause of my epilepsy. My brother Siddharth carries the same change, but my epilepsy has been much milder over the years. And I would like to talk to you as this helped me develop a unique perspective of our conditions and a deep interest in healthcare. I was diagnosed with epilepsy by Dr. Peter Berman, who at the time was the head of child neurology at CHOP. Dr. Berman helped provide us with a few clever strategies for our genetic condition, good sleep hygiene, sufficient hydration, and methods to keep our body temperature cool. My own struggle with accepting my epilepsy diagnosis started in elementary school. I had lots of difficulties, and I started to realize that everyone else around us did not struggle as much as we did. This was frustrating and honestly isolating. In high school, things became clear when we finally received our SCN1A diagnosis. Yes, I do know my G.C.P. Thank you, Dr. Helbig. Siddharth and I carry a pathogenic P281L, that's P281L variant. This information really helped me understand and accept my epilepsy. At the same time, things improved in my social life, and I was busy hanging out with my peers, doing things that typical teenagers do. One thing that was tricky, however, was my tendency to have seizures when my sleep was off. Typical SCN1A. Then, after graduating in 2020, I started undergrad at Temple. First in neuroscience, and then I switched to psychology because of my interest in the field. I also started volunteering in a mental health facility near my college. Then I discovered the summer student program at NGen, CHOP's epilepsy genetics team. I applied and was accepted. I was excited to actually work in the program that found my brother's and my mutation. I ended my first junior year semester successfully, excelling both academically and socially. I don't mean to brag, but this really boosted my self-esteem and confidence. This allowed me to spend more time with my family and dive more deeply into research. My brother Siddharth has typical Dravet syndrome, even though we have the same mutation. You've heard stories like ours here at the conference, and I am one of those stories. His seizures have always been more frequent and difficult to treat, and started much earlier. And I'm actually here to help my team recruit for the Dravet Genome Project, and we hope that we can understand why this is the case. So this is my personal journey with SCN1A and beyond. I'm deeply influenced by the experiences with my brother and how the providers who helped were my role models. And what I learned was that I would really like to advocate for those in need. And I hope that I can meaningfully contribute to healthcare in the future myself. Thank you for allowing me to share my story. This is my first time at the DSF conference. I'm very, very humbled by the community that you have built. Thank you once again.
Thank you so much, Arjun. This is really exactly why this project is so important that we have going on. So I'm going to explain a little bit in more detail what this project entails to hope make sure that we get everyone's samples before we leave today. So I don't have any disclosures except that we had collected many socks to bring home with us, I think, from AES this year from Dravet Syndrome Foundation, which was great when they came to visit us. So today we'll go over why this project is important, what we plan to learn over the next few years, and how you can participate in this project. So why is this project important? So for some background context, these are genetic diagnoses that we've seen in our Engine Clinic, which is our epilepsy neurogenetics initiative. We are one of the largest epilepsy genetics clinic in the world, actually. We've made 477 new genetic diagnoses, which is probably an old number at this point. And you can see the list of the top genetic diagnoses that we've seen in our clinic. A lot of the ones in the red are diagnoses that may have come as a second opinion to us, and the blue are the ones that we've been able to diagnose. And you can see that SCN1A is number 2, just because we have an expertise in STXBP1. But shortly behind that is SCN2A, and so on and so on. But SCN1A, as we know, is the most common genetic cause for epilepsy. So you probably have seen this on their website. So there is a whole spectrum of SCN1A related disorders, all the way from familial hemiplegic migraines, all the way to what Dr. Helbig was talking about, more of the gain of function, epileptic encephalopathy, SCN1A, and then with Dravet on the more severe spectrum as well. So really, why is there this spectrum of patients? So our project, we're going to look at the genotype and then also phenotype all of the patients. So to kind of explain what that means, the genotype is that C dot or G dot, C dot, P dot, and where the actual mutation is, what that mutation is, and that's the information we'll collect. But then how does that mutation present? That is what the phenotype is. Why do some kids have a more severe presentation of their intellectual disability or autism versus other ones, even within the same mutation at the same spot on the gene? Multiple other characteristics that we're planning to explore as well. And that's all information that we're going to be collecting and then doing an entire phenotype reconstruction of everything throughout the lifespan, month by month. So what do we plan to learn over the next few years? So Dr. Helbig presented this yesterday, but this is work from Ann Apprentice, who is out there helping us with our sample collections from a sample of 55 individuals with SCN1A. So we saw that there was a mean age of onset at 6.9 months of their seizures. It was most common to see a monthly frequency of seizures, and then the second most common was to have more than 5 seizures daily. So using this, we're able to use the PELIS scale, which is a more standardized scale of how to interpret and kind of quantify everyone's seizures, to be able to make graphics like this for comparison to other disorders, and even comparisons within SCN1A itself. So 46 out of the 55 individuals we had information on experienced prolonged seizures, and at all months of life, at least one participant or greater exhibited daily seizures, and at the same time as well, at every month interval, one or more were seizure-free. So really just the spectrum of seizure control with that. So other clinical features that we can see, so from this cohort, 40 out of 55 individuals had neurodevelopmental differences. The onset of delay correlated with the seizure onset, as you can see in the bottom graph. 44 out of 55 exhibited atypical behavior. 41 out of 55 displayed differences in motor and movement, including their tone, balance, and gait, which we heard a lot about yesterday. And then you can see the top graphic here. I don't know how to use the laser pointer, but the top graphic, you can see those kind of charted out, and it's by months on the bottom, and then the number of individuals at top. So you can see that seizures are the most common phenotype, followed by neurodevelopmental delay, and then followed by gait and autistic behavior. The autistic behavior might be a little bit lower because this cohort did include all SCN1A patients that we had. So standardizing the clinical data. So this is when HPO terms come into play, which is the human phenotype ontology. So that is what all those terms are on the right and even on the left to really kind of put these terms and trying to standardize this data that we have for everybody. So these are a lot of terms that are used when looking at whole exome sequencing, but I think probably the majority of SCN1A is found on an epilepsy panel where these are a little bit less important to take note of, but this is something that we're going to be diving into when we're looking through the records of your child or loved one with SCN1A. And there's been a lot of work, even how do we standardize the clinical data of a seizure even further? So it's not just a seizure. Every seizure is so different from each other. So then how do we break it down further? So we break it down by, is it motor? Is it a motor seizure? Is it a focal onset seizure? You can break it down further than that. Is it a focal clonic seizure? And then even further, is it a focal hemiclonic seizure? And you can do this with all different types of seizures and really breaking it down into getting the most accurate description of that type of seizure. So when we get your child's sample, we're also going to be following up to get medical records from them. So we are going to make a CHOP medical record for all of the patients' samples that we have, and the records are going to be stored in Epic, which is extra secure. From there, hopefully we can do a lot of care everywhere, which is available at a lot of the big hospitals now, which is great to be able to easily get that information. If not, you'll be able to email us that information, or you can also, we could set you up with a MyChop account, and you're welcome to upload records to the MyChop account directly if that is something you're more comfortable with. Our email is very secure. We have a fax number that's secure as well. Those are all ways that you could send the records over to us, and we're happy to answer any questions about that as well. So how can you participate? So you might have saw this promo go out, and the official title of the project is Generating a Shareable Clinico-Genomic Data Resource for Dravet Syndrome, led by Dr. Helbing and Dr. Goldberg. So we are going to whole genome sequence 500 individuals with SCN1A-related epilepsy, which is a huge undertaking, and it's a lot of patients. But just to kind of talk about genome a little bit and why we're picking to do this type of testing is because you can get a lot more information as compared to just an exome. Exome is super important, and the cost has been driven down significantly over the past 2 years, as exome is able to diagnose 85% of genetic disorders. It would definitely diagnose SCN1A. But having the genome sequenced completely for all of these 500 individuals is going to allow us to do this one-time sequencing and then use this information broadly as compared to other different testing techniques. So with us sequencing all of this information, you will not receive the raw data of this information because it's research, but then we're going to be looking at the genome to see what other genetic modifiers are there that might be contributing to the individual's phenotype and severity of the spectrum of SCN1A related disorders. So this is the information we're going to use, and then we do plan to have this available for researchers across the country as well. So please visit us at, we moved our table to be right outside of the Dravet activity room. We have buccal swabs, so just a cheek swab, but we just ask no eating or drinking for about 30 minutes before, so maybe right before lunch we can grab you. We have 26 samples in hand at the moment from the conference, but I think we're missing the other half that are here right now, so we will be here until about 6 p.m. today, so if you're able to stop by, that would be great. And then everybody received one of these postcard flyers as well in their bags with the email address listed as well. So you can go visit Johanna and Anna, who are listed in the picture there, and we're happy to answer any further questions that you have about the project. I feel like I had something else to say, but that might be it. I know there's going to be a lot of questions. Oh my God, thank you. Patients who are online, online and are not here, we are able to send some patients home with test kits that you're able to mail back to us. We might run out of those, but we will be able to ship you a test kit at home with a prepaid FedEx bag that you can ship back to us for that testing, and we'll be in contact then to receive records for everyone. Yes. Oh, I have a few more slides I forgot.
Hi. Are you going to share the information that you learned to the individual patients about their potential genetic modifiers?
Not at this time because it's on a research basis, and we really need to learn if those genetic modifiers even have any, one, if they have a clinical correlation, and two, is there something that would even change based on that clinical correlation, based on their care? So not at this time. We would not be sharing that information. We need to learn how first to interpret that information.
Are you looking at only patients in the United States?
So currently at this time, only in the United States. We are, when we get home, looking into the legality of shipping biosamples from other countries, because that is something that can get into murky territory, but we are trying to look into that. I will also say we are really trying to push for a more diverse population from the SCN1A and make sure that the race and ethnicity matches what is seen around the country. Yes.
Question, once you've done the research and understand the impact of the different genes and how they interact with each other, are there further opportunities to use this data? For example, understanding why certain medications work for some kid and not another. Can we build upon the data?
Yes, definitely. So the medication part will definitely be built into the phenotype to kind of say what medications have children or adults been on at that time in comparison to their seizure control. And then that's big data that we're able to then generate and kind of show like what has been the spectrum of medication in relation to the efficacy for seizure control. And we plan on making this an available biobank then for researchers to have access to, and that's something you'll consent into, and then have the optional ability to consent if you want your information shared with, de-identified information shared with industry as well. So this is going to be a huge biobank of information, and having that raw genome data paired with the phenotype is really valuable information that we're going to be able to share with everybody. Yes.
Can you remind us if there's any age limit on patients participating?
No age limit. We would love everybody from every age to really get the spectrum.
And then can you say one more time, these are questions coming in from online, can you just say one more time how families can get involved if they're not
Families
here right
can
now?
get involved by emailing scn1a@chop.edu. Hopefully it's easy to remember. If not, there is that postcard that you got in your bag. And also Dravet Syndrome Foundation pushed out our flyer recently as well. So that information is there. I guess that's the best way. If you forget, you could message Dravet Syndrome Foundation. They'll put you in touch with us.
That's what I was gonna say.
Any other questions?
So I don't have a question. I want to make a comment. Maybe you can comment on my comment. I think all of you know that when you're having a situation where you don't have good seizure control and you're looking for a new medication, fortunately, there's a lot of options, but the reality is what will work is a trial and error process. You all know that. Very frustrating, very time dependent. Sometimes it works for a while, sometimes it doesn't. So my hope that through this initial research grant here, we can get to a point where knowing your genotype, we can tell you what the best polytherapy would be for your loved one. That's what I see as the ultimate goal.
Yes, I agree completely, and that's something that's going to be very exciting to see as well. And we've been able to reproduce a lot of that information for other genetic disorders, and also seeing. I just lost my train of thought right there, but exactly. Especially, I think with a lot of the trials right now, you have to have pretty frequent seizures to be able to enroll in those trials. So what can you do in the meantime? And this information will give us light of what medications are already out there and approved that could be a good option for your child or loved one.
Can you talk to us about at the end of, what CHOP's doing and gathering all this data and doing your inquiries, what happens to all the data after the study? Would it be something that we could probe again? Can we collaborate with other researchers? When we know more in 5-10 years, can we go back to these data sets?
Definitely. So this is all going to be shareable information with researchers around the country and world through Cavatica with de-identified information with their genotype and phenotype. And I think we only will probably continue to just keep building that data that is there and updating as we go along, because there's so much in the future that's coming that it's going to be really important to keep that information up to date.
Hi. First, I just want to say this is incredible. But I wanted to ask, and apologies if I missed this earlier, but what are the general timelines you're working with? Like, do you have an expectation of when you'll have all 500 samples and a final readout?
Yep. So this is the plan is for a 3-year project. We're planning to send samples in batches of about 100 to do the genome sequencing. So we should be close to our first 100 pretty soon. So we can start doing that, and then including the phenotyping, which takes some manual labor on the back end as well. But kind of keeping that information going, and hopefully we can even publish earlier than with smaller samples. But the goal is still to get the 500.
This isn't a question, but it's just a comment to everyone here that's hearing this, that feels excited about it, that's participating. Remember that we need 500 patients. So when we go back home next week, let's talk about this. Tell people that you're excited about it. Tell them that you're participating. It's a pretty low, ask. I know parents get asked to do so many surveys and research things, but this could be really big. It's the biggest grant DSF has ever funded, because these are the questions that we hear the most, that the community wants to hear. So let's try to light the community on fire to participate in this. So I will go back and do the same, but I ask all of you guys to join me in that and talking to the whole community, because I think if we all come together, we know if we all come together that big change happens. We've seen it this whole conference. So just encourage you guys to talk about it as much as you can when we get back.
And I just want to double down on this. So we only have half of cheek swabs of the Dravet people who are here. So if you have a loved one with Dravet who has not been consented yet, please do this. The timeline depends on you. We need 500, and this is something where we really want to have the community come together, and we can do this, but we need you.
I really feel like I have to hurry up and get one of those cheek swab things and take it home to my kid, like now. Like, drop the mic and go home.
All right, great. Thank you so much for the opportunity to talk about this project.